Hello, everyone. Welcome back. Today we are going to be talking about radian measure and angles on the Cartesian plane. So, you remember last term, you would have learned about the the degree measure of our special triangles for trigonometry. I think a lot of people would. But if not, that's all right. Today I'm going to talk about those same measures, but in radians. So, here we have our special triangles. Okay, so instead of 45, 45, 90, this is now pi over 4. Sorry, not pi over 2, pi over 4, pi over 4, pi over 2. And these are 1, 1, root 2. Okay, so this is our first special triangle. Our second special triangle is pi over 6 over here, pi over 3 there, and then a right angle right there, like that. Or the other way we could word this is we could have root 3, 1, and 2. And if you look closely, these are the exact same triangles twice. Just in one of them, I multiplied by 2 all the sides. So it's bigger, but it is the exact, it's a, or I shouldn't say it's the exact same triangle then, because like I said, I multiplied the sides by 2, but it's a similar triangle. These two are similar triangles. Okay. Also, here is a copy of a unit circle. Do copy this down, take note of this. This is the unit circle, just as we're used to seeing it, but this unit circle is different because it also has the radian measures on there as well. So that's the key difference there. Well, without further ado, let's get into some problems because I'm sure that's why you really all came, was to actually do some questions. Example 1 says, for each trigonometric ratio, find the value of each ratio by sketching each terminal arm and using each corresponding acute angle. Okay, so for this, we need to remember the cast rule. Okay, so the cast rule is like this, where we have CAST like this. One thing to remember though is that C starts in quadrant 4, not quadrant 1. Okay, so it's CAST with C starting in quadrant 4, or some people who like to start in quadrant 1 and remember ASTC, or all students take calculus or something like that. Whatever mnemonic device you need to remember it, just make sure that you know that. Or actually, I have a previous lesson where I talk about why is this. So if you are curious as to why, why are all of them positive in quadrant 1 and then only sine in quadrant 2 and only tan in quadrant 3, only C in quadrant 4, I do talk about that in another video if you're interested. So we'll link that below. Anyway, let's move on. So we have CAST, and then here, of course, we have 0. And then here we would have 90 degrees, which is the same as pi over 2. Then we have pi, which is 180, then 3 pi over 2, and then 180 when we get back to 0. Or, sorry, I shouldn't say 180. Or, sorry, it should be 360, first of all. And second of all, we're not doing degrees, we're doing radians, so it should be 2 pi. So that 180 was completely wrong. But anyway, 2 pi. There we go. Okay, so now we have sine of 2 pi over 3. Well, let's see. That is going to be in quadrant 2 because 2 pi over 3 is larger than pi over 2, but it's smaller than pi. So it's going to be like this. Okay? 2 pi over 3. Like that. And then how much do we have left? We just have pi over 3 left. So what does that mean? That means this is a special triangle, right? This is this, 1, 2, root 3 special triangle where we have our opposite being root 3 and our adjacent being 1. And then we have 2 over here. So we want to know what is sine. Well, first of all, sine is positive in this quadrant, so it's going to be a positive answer. And sine is what? Sine is opposite over hypotenuse, right? So the opposite is root 3 and the hypotenuse is 2. So the answer is going to be root 3 over 2. And there we go. We did it. Okay, let's do some more examples here. Here we have cosine 3 pi over 4. So let's draw out our unit circle again. Or sorry, not our unit circle, just our little diagram here. And then here we have 0, pi over 2, pi, I got it, 3 pi over 2, and then 2 pi. So for this one here, it's 3 pi over 4, which means we're going to go over here. And what's left? Just pi over 4. So here we'd have pi over 4. Here we'd have 3 pi over 4. And so this is which special triangle? Well, this is going to be the pi over 4, pi over 4, pi over 2 special triangle, which is the 1, 1, root 2 special triangle. So given that, what is cosine of this, of the alternate acute angle? Well, it would be 1 over root 2, but wait, cosine is negative here, right? Because only sine is positive, right? We have an S for sine is positive. That means cosine and tangent are negative, which means that this is going to be negative 1 over root 2. And that's our answer. Awesome. All right. Now let's do cotangent 11 pi over root 6. So cotangent, just a reminder, is the inverse of, not inverse. It's the reciprocal of the tangent. Okay, so rather than just as tangent is opposite over adjacent, cotangent is adjacent over opposite. Okay, so let's do it. For this one, I can tell will it be a special triangle? Actually, yes, it will be a special triangle. Let's draw this. For some reason, I was thinking maybe it wouldn't be, but it actually will be, it turns out. We'll go all the way around here for 11 pi over 6. And then here we just need one more pi over 6. Okay, and then what's the answer going to be? Well, this is going to be pi over 3. And then we know exactly which special triangle this is. On our special triangle, what is opposite to pi over 6? It's 1. And what is adjacent to pi over 6? Root 3. And 1. There we go. And this one is 2. And then we have our cast rule that we got to add in. So what is the adjacent over the hypotenuse? Or sorry, the opposite over adjacent here? Well, opposite is 1, adjacent is root 3. And then we got to swap them, right? Because cotangent is actually adjacent over opposite. So it would be root 3 over 1. So just root 3. And then there's one more thing. Only cosine in this quadrant is positive. Everything else is negative, including tangent, and by extension of that, cotangent. And so therefore, we have a negative sign here. All right, let's do one more example with secant of 7 pi over 4. Okay, so let's draw that out. Okay, so 7 pi over 4. So that would be all the way here. And all we're left with is pi over 4. So this is a 1, 1, root 2 triangle. And with cast, we know that only cosine is positive here. Now, secant is the inverse of cosine, so by extension, secant actually is also positive here. And cosine is adjacent over hypotenuse, which means that this is going to be the opposite, right? The reciprocal, I shouldn't say opposite. That could mean many things. I should say reciprocal. The reciprocal is hypotenuse over adjacent, right? Hypotenuse over adjacent. So that's going to be root 2 over 1, which is just root 2, right? And we know it's positive because cosine is positive, and by extension, secant is also positive. Good. All right, let's move on to example 2. Example 2 says, determine the exact value of each trigonometric ratio. So this means when it says exact value, that means we don't round, right? Whenever we round to the nearest value, we're never giving the exact value. We're giving an approximated value. So rounding is a way of giving an approximate value. Giving an exact value is the opposite of that. Giving the exact value means we're just going to leave things in with square root signs or with pi or whatever it happens to be. Anything that we would have to approximate, we're just going to stop there and not approximate it because they want an exact value. Okay, so with that in mind, let's figure out the exact values of each trigonometric ratio, or the non-rounded values. So this first one is cosine of 3 pi over 4. So let's do the same thing we did before for this one. 3 pi over 4. Well, here's pi over 2, and here's 3 pi over 4 like that. And so what do we have left here? If this is 3 pi over 4, we have just pi over 4 left. And that's going to be 1 root 2. So what's cosine, right? What's cosine with this this one? That's going to be adjacent over hypotenuse, which is 1 over root 2. And then let's use our cast rule to check if this is going to be positive or negative. And as it turns out, it's actually going to be negative because it's in quadrant 2, and only sine is positive in quadrant 2, which means cosine is not positive. It's negative. Okay. Then we have tan of 2 pi over 3. There we go. All right, so let's do it. Let's do this one. So we have 2 pi over 3 here. So that means we have an extra pi over 3 here for our relative acute angle. And that means this is pi over 6, which means we have this one here where we have root 3, 2, and 1. Okay, so then we have tangent, which tangent is what? Tangent is opposite over adjacent. So opposite is root 3, and adjacent is 1. So this is going to be equal to root 3. And it is in the sine quadrant, the quadrant where only sine is positive, so therefore tan must be negative. So I'm going to plop a negative sign right there for negative root 3. Awesome. Okay, let's move on to cotangent. Cotangent. There we go. Okay, so cotangent of 7 pi over 6. Okay, so here we have 0, pi over 2, pi, and 3 pi over 2, like that. Okay, and then we have our cast. And we have 7 pi over 6, which that's going to end up in quadrant 3, because here we have 6 pi over 6, right? A full pi. And then we have one extra pi over 6 sliver like that, which means this is pi over 3. And then we have root 3, 1, and 2. And so what is tangent of pi over 6? Well, that's going to be opposite over adjacent, so that's 1 over root 3. Now this is cotangent though, so it's actually going to be the reciprocal of that, so it would just be root 3, and it would be a positive root 3 because tangent is positive in this quadrant, and by extension of that, cotangent would also be positive. Okay, let's try D. Let's try D, where it's 4 pi over 3. That's also going to end up in quadrant 3. So we're going to do a pi over 3 extra in this sliver, and that means that we have the root 3, 2, and 1, and we need to find CSC of 4 pi over 3, right? Okay. So for this one, let's think about it. CSC is what? First of all, cosecant, right? That means that it is the same. Yeah, it is the reciprocal of which one? We have sine, cos, and tan. It is the inverse of the sine function, right? This is the inverse of the sine function, cosecant. Um, so therefore, it is going to be, well, what's sine normally? Well, sine is opposite over adjacent, so that's going to be root 3 over 1, right? So this time it's going to be different. Or sorry, it's opposite over hypotenuse. My apologies. So sine is opposite over hypotenuse, which is root 3 over 2. So it's going to be the opposite, the reciprocal of that, which is 2 over root 3. And also, it's in a quadrant where only tangent is positive, so therefore cosecant would be negative because sine is negative, so this would be negative as well. So there we have it. Okay, let's do example 3. Example 3 says, the following points lie on a terminal arm of an angle in standard position. Sketch each angle, determine the radius, and calculate the value theta in radian measure. Okay, so let's do it. Let's start with this one here, 3, -8. So that's going to look like that. And here we have 3, and here we have -8. So first of all, we need to find the radius. The radius is the same as the hypotenuse in this case, right? The hypotenuse of this right triangle that we have is the same as our radius. So therefore, the radius is equal to the square root of 3 squared plus -8 squared based on Pythagoras' theorem, which means that's going to be 9 plus 64, which is 73, which is going to be about 8.54. Okay. And then it says calculate theta in radian measure. So how do we calculate theta? Well, let's do tan theta. So tan theta would be equal to, let's see, opposite over adjacent, which would be what? That's going to be -8 over 3. So therefore, theta would end up being -1.21. And there we go. Now let's say they wanted to know, because we just defined it this way. What if they wanted to know about this full, oh, shoot, I erased that. Okay. What if they wanted to know about this full thing? What could we do then to find this? Let's call this angle, I'm not sure. Let's call it psi. There we go. So to find this, we would just have to do 2 pi radians minus minus this one. And we would get the answer, right? So that's how we could do it if they wanted that answer. Okay. Now let's move on to this one here where we have -5 minus 6. So we have something like that. So that means we have -5 over here and -6 here. First thing they want is the radius. So the radius is, by Pythagoras' theorem, is -6 squared plus -5 squared, the square root of that. And that's going to be the square root of 36 plus 25, which is going to be about 7.81 approximately. And then we're going to find the angle using tan right? So tan theta is equal to -5, or opposite over adjacent. Oh, I got these mixed up. Shoot. I guess that doesn't matter for our radius, but I'm just realizing this was supposed to be -6 and this was supposed to be -5. Sorry about that. And then here we have -6, right? So we have our tangent here. And then we're going to say that theta, using our inverse tan function, is 3.835. Very good. Okay, and that does account for this whole thing. With this one, it did -1.21, right? Because it was going backwards. It's 1.21 less than 2 pi, right? In this case, they're going forwards, right? It's 3.835. And of course, as we know with our sinusoidal functions, they just repeat over and over, right? So there's multiple different inputs. In fact, there's infinite many inputs that give us the same output. Of course, they are functions, so the opposite can't be true. We can't put one input and get multiple outputs. But the opposite is possible and does happen all the time with sinusoidal functions, where we can get the same output through multiple different inputs. In fact, infinite inputs. Good. All right. Example 4 says, if tangent theta is equal to -7/24, where 0 is less than or equal to theta is less than or equal to 2 pi, so just that first cycle there, not anything more, find the value of theta in radian measure. Okay, so how would we approach a question like this? Well, let's see. We know that the tangent theta is -7/24, right? So what does that tell us exactly? We know that tangent theta is equal to -7/24, which means that theta is what? Well, theta, if we map it out, would have to be -0.28, or what's another option for theta? We could add, we could add a pi to that and get the same thing, right? Because we could have this angle -0.28, or we could have something 180 more and we get the same thing. And even by the cast rule, it's the same either way. They're negative in both those quadrants, right? And so we could add 180 to this and get the same thing, right? Now, what's 180 in radians? Well, that's just pi, right? Just pi. So we add pi, we get 2.86. And therefore, the value of this in radian measure, that's between 0 and 2 pi, is 2.86. This is our answer. Now, I know the other one was the answer we got from our calculator, but it specifically said that the correct answer that they wanted had to be between 0 and 2 pi, so that's why we had to add the pi on there to show that, right? And then here we would have 2.86. Good. Let's do one more example here. This one says, if secant theta is 4/3, where where our domain is from 0 to 2 pi, find the value of theta in radian measure. Okay, so we know that secant is 4/3, which means that cosine theta is 3/4. Simple as that. Now, if we plug that in our calculator, we'll find out that theta is equal to 0.72. And that is a correct answer for this, right? Because this is between 0 and 2 pi, so it is a good answer. It is a good answer. Okay, there is one other good answer that I would accept as well. So this is a good answer, first of all, because it is between, it is within our domain. The other good answer is, let's say that we said, well, wait, we would also have, cosine being positive in quadrant 4. So couldn't we also do all the way up to here just minus 0.72 in quadrant 4? And yes, we could. And that would get us to, if you plug that into our calculator, of 2 pi minus 0.72, we would get to 5.56. And yes, that would also be a correct answer as well. So there's actually two correct answers for this one. And even going back to the last one, actually, I'm wondering, would there be another correct answer? Yes, we could add 180 again, and we could get this second one, the minus 0.28 that we got, and that would also be another correct answer here. So when they ask for the value in radian measure, either of those is acceptable. Now, in some questions, they may even ask find all possible values. And if they ask for all possible values, make sure you put all possible values within that domain. Don't just put one and be done. If they just ask for one value, then either one of those is correct. So just depending what the question's asking for. Here it just says find the value instead of the values. So I would imagine just one is okay here. But if they do ask for all possible values, or if they ask for both values, or they word it in such a way that makes it clear that they want both answers, they want two answers, do put down both the answers within the domain. Awesome. Very good. All right, well, that is that. That is everything for today. Good work today, everyone, and we will see you back for next day. Bye, everyone.